All right, let's jump right into this explainer. Today, we're looking at something that, honestly, we kind of take for granted now, but it's actually one of the most fascinating stories in human history, the science of vaccines. We're going to explore exactly how we learned to fight back against the microscopic pathogens that literally used to rule our world, and how we continue that incredible fight today.
Here's our roadmap for today. We're going to cover 1. The forgotten threat. 2. Our internal defenses. 3. How vaccines train us. 4. The power of herd immunity. And finally, 5. Eradicating a global killer. Let's get into it.
Part 1. The forgotten threat, when microbes ruled. And believe me, they really did rule.
It's so easy for us today to just forget the sheer terror of infectious diseases. Our source text really hits the nail on the head here, noting, "To have held a child suffering and dying with nothing on this earth to save them is the most heart-wrenching experience of the human spirit." I mean, wow. Think about life before modern medicine. A simple scrape could mean tetanus. A stray dog bite, absolute panic over rabies. Microbes didn't care who you were, and literally everyone was susceptible to the anguish they brought. Our reality has totally shifted since then. We used to live right alongside these terrifying relics like smallpox, polio, and diphtheria, which, by the way, was brutally known as the Strangler. But today, these are basically extinct or exceedingly rare in the developed world. We don't walk around constantly looking over our shoulders for them anymore. And this incredible shift, this total game changer, is all thanks to a medical marvel that kicked off in the early 19th century: vaccination.
Which brings us to part 2, our internal defenses, the battlefield within.
So before we can really grasp how vaccines work, we have to look closely at our own biology. We're naturally equipped with innate immunity, which holds off initial challenges, and acquired immunity, which acts like a highly trained, targeted defense force. But how does that special forces team know exactly what to attack? Well, the secret lies in this tiny biological display case called the Major Histocompatibility Complex, or MHC for short. It sits right on the surface of your cells and literally presents pieces of an invading bug to warn the rest of your immune system that, hey, we've got a breach.
Think of it like an incredibly intricate security protocol. First, a host cell, like a macrophage, just swallows the bug whole. Next, digestive enzymes go to work and break that bug down into harmless little pieces. Then, the MHC grabs one of those digested pieces, mounts it, and pushes it right up to the cell's surface. It waves it around like a red flag to activate our specialized immune cells, specifically our T and B lymphocytes. It is just a brilliantly elegant biological alarm system. Once that alarm goes off, our acquired immunity launches a massive, two-pronged attack. On one side, we have humoral immunity. Think of this like a barrage of archers. B cells crank out highly specific antibodies that circulate in our bodily fluids to neutralize the threat from afar. Fun fact, the word humoral actually comes from the Latin word humor, which means fluid. Then, on the flip side, we have cellular immunity. This is your close combat force. T cells don't make antibodies. Instead, killer T cells directly destroy the infected cells, while helper T cells coordinate the destruction. The absolute most effective vaccines out there are specifically designed to trigger both of these powerful responses.
And that brings us perfectly to part 3, how vaccines train us, the ultimate simulator.
Basically, vaccination is just introducing a microbe on our own terms. It primes the immune system before a real dangerous infection hits. But there are a bunch of wildly different, really clever ways to do this safely. We can use a live but related microbe, which is what we did for smallpox. Or we can inject completely killed microbes. That's the strategy for some polio and flu vaccines. Sometimes the actual threat isn't the bug itself, but the toxin it produces. So in those cases, we use altered, harmless toxins called toxoids for things like diphtheria and tetanus. We also use live, attenuated, meaning weakened, microbes for measles and mumps. And then finally, we have the revolutionary messenger RNA, or mRNA vaccines, like the ones for the coronavirus. Honestly, this one is basically science fiction. It instructs our own human ribosomes to build a viral protein just to trigger that crucial immune response.
And the wild part is, scientists are constantly refining this stuff. Take pertussis, which you probably know as whooping cough. The earliest vaccines injected the entire dead bacteria. And while it definitely worked, a specific component, the lipid A endotoxin in the bacteria's cell wall, sometimes gave kids mild fevers and made them super fussy. So researchers went back to the lab. Modern preparations are now acellular. That means they only use highly specific, isolated pieces of the bacteria. It completely bypasses those toxic reactions while still granting that vital, protective, acquired immunity.
Now, to make sure these highly refined vaccines actually do their job, we sometimes need a little extra boost.
Enter adjuvants. The word comes from the Latin juvare, meaning helper. Adjuvants are non-toxic substances mixed right into the vaccine, and their only job? To actively attract your immune cells straight to the site of the injection. It's quite literally like firing off a biological flare gun. The more immune cells that show up to pick up the vaccine material and haul it to the lymph tissues, the stronger and more robust your acquired immune response is going to be.
All right, let's zoom out from the microscopic level and look at the big picture in Part 4, the power of herd immunity, the numbers game.
Vaccines are a marvel, for sure, but they aren't 100% perfect for every single person. For instance, a typical flu vaccine might trigger a 90 to 95% antibody response if you're in your 20s or 30s. Pretty great, right? But by the time you hit your 50s, that drops to about 80%. And for folks over 70, it's hovering around 70%. Obviously, it's still way better than nothing, but it's not an absolute guarantee. And listen, this is exactly why younger, healthier people need to roll up their sleeves and get vaccinated. We do it to build a protective wall around older, more vulnerable folks whose aging immune systems just might not mount a perfect defense anymore.
Which brings us straight to the concept of herd immunity. Now, herd might sound a bit, abrasive. Nobody really wants to be compared to cattle, but the concept itself is beautiful. If a disease enters a population where almost everyone is already immune, it just hits a brick wall. Without vulnerable hosts to jump to, the organism simply dies out. But here's the catch. To completely thwart an infectious disease, we need an incredibly high community compliance threshold. Usually, around 85 to 90% of the population needs to be immune. And because some vaccinations don't take perfectly, like we just talked about, hitting that target requires a massive collective community effort.
And when we do hit that collective target globally, the results are literally miraculous. Let's move to Part 5, Eradicating a Killer, the Ultimate Victory.
Smallpox was an absolutely devastating scourge, but it had one major weakness. It had no animal carrier, which made it the perfect target for global eradication. So, how did public health workers actually pull off the impossible? They used this ingenious epidemiologic tactic called ring vaccination. Basically, whenever a rare case popped up, heavily immunized health workers would rush in. First, they identify the victim. Second, they immediately vaccinate their closest contacts. Then, they vaccinate people a little further away, constantly working outward in expanding rings. Since you can actually successfully vaccinate against smallpox even 4 to 5 days after exposure, this ring strategy literally trapped the virus, cutting off its escape routes and stopping the spread dead in its tracks.
And this exact strategy led to one of humanity's absolute greatest achievements. In 1975, the very last known case of the deadly variola major strain popped up in India. 2 years later, in 1977, a cook in Somalia named Ali Mao Malan contracted the last wild case of the milder variola minor strain. Now, the World Health Organization always waits 3 full years to be absolutely certain that there are 0 lingering cases out in the wild. And so, in 1980, under the leadership of Dr. D.A. Henderson and a massive international team, the WHO officially declared smallpox eradicated from the face of the earth. Just incredible.
It's an astounding victory for science, right? But the war is far from over. Infectious organisms are incredibly adaptable. They're constantly mutating, always looking for a new biological niche to exploit. We've gone from injecting whole microbes to engineering mRNA, just continually refining how we prime our internal defenses. So, the ultimate question I want to leave you with is this. As we continue this amazing journey of understanding our immune system, how will our medical marvels adapt to outsmart the next unremitting threat? The science of vaccines has saved countless millions of lives, but the race against the microbes never truly stops. Thanks so much for joining me on this explainer today, and keep questioning.